Okay, now we're going to look at a direct variation and what the graph might look like. So Tanika borrowed $400 from her parents to help pay for driver training. She needs to have a driver's license to apply for a job that she wants after she graduates. She has an after-school job and agrees to pay her parents back at $50 at the end of each week. Tanika is keeping track of how much she owes her parents on a weekly basis. So at the beginning, at week 0, she owes the total $400. And then every week after that, she's paying $50. So there's $50 coming off of that each time. So what are the initial value and the rate of change? So the initial value is what it starts at, right? Which would be how much she owes in week 0, which would be $400. The rate of change is how much the dependent variable changes as the independent variable changes by 1, right? So as the independent variable, which is the weeks, goes up by 1 each time, the rate of change is what is happening over here. And what's actually happening is we're going down by 50. So I'm going to put minus 50 because it's going down. So the rate of change would be a negative $50 per, oh, not hour, because we're not dealing in hours anymore. We're dealing in weeks, okay? So then it wants us to create a scatter plot of the data, and I already created one here. So what I did is I put the points in for all the weeks right up to 8 weeks. So you can see some of them here, like at 0 weeks, $400 is owed. At 1 week, it's $350, 2 weeks, it's $300, and so on and so forth. And you can see all those points were plotted on the graph. Decide whether to draw a line, a dashed, or solid through the points. So the idea of drawing a line through the points is, does information exist in between them? So does something change between week 1 and 2, but like in between there? So like 3 days into week 1. And no, because she's paying a lump sum at, let's say, the end of each week, for example, the days in between, nothing is changing. So we're actually not going to connect the dots. This is data is what we call discrete data, which means nothing is changing in between each point. So we do not connect the dots because the data is what we call discrete, which means nothing is changing between the points. Okay, so nothing is changing 3 days into week 1. Nothing changes from week 1 until we hit week 2. How does your graph show the initial value and the rate of change? So the initial value is this y-intercept right here. So there it is. This is the, oh, sorry, I don't mean to use my highlighter for this. This is the initial value. And the slope, which is the rise over run, which we can see was calculated here. So we went, the 2 points they picked, we went down by 100 and over by 2. You could have picked any 2 points and just done the rise over run. They see the slope is negative 50, which you can see is the rate of change. So that y-intercept is the initial value and the slope is the rate of change. How do you know that the graph represents a partial variation? So things we look for in a partial variation, no 0, 0 point, right? And it is still linear. So you can see that by the fact that if I did connect these dots, it would be a straight line. You can also see it by the fact that there is a constant rate of change. Suppose she paid back $80 a week instead of the $50 a week. How would the graph change? So the rate of change would be negative 80 instead of negative 50 with a higher value. Even though it's negative, it still has a higher numeric value, which means it's steeper. So the graph would be steeper. It would look something more like this as opposed to this one, okay? So the graph of a direct variation, it has this y-intercept not down here like we have with the direct variation, but up somewhere along that y-axis, but it is still linear. So those are some important things to note about the graph of a partial variation.